Well, thanks everybody for coming today, and it's always tough not being being the last speaker before the break. So I too will try to be interesting and entertaining for you. So I'm here to talk about the use of virtual reality headsets for training. So this is not a new topic. This is something that's been around for at least 30 or 40 years. People have been thinking about using this technology and trying very many ways to do it. What I am here to do is give you some information on what we see going on right now, because it does seem that we're at a real tipping point where this technology is really moving into active use and actually really changing the way that training is done. So I will spend some time to talk about that and a little bit of the background in that. So I have always been someone that's interested in disrupting things. I don't know what it is, what my background is to that, but I was working for Evans and Sutherland back in the late 1980s, and looking at the way simulators were built with the big expensive displays and domes and things like that, and I kept saying there's got to be a better way. And reading a magazine one day, I saw Jaron Lanier in this headset there that this company called VPL Research had developed, and I said, this is it. This is really going to change things. So I jumped on an airplane with a couple of our program managers. We went out to Silicon Valley and went to Redwood Shores to visit them. We put this headset on, and he said, this is interesting, but this is not the way. Because where the technology had promise at the time, there was all sorts of issues with that in the sense that the resolution of the headsets wasn't there. The latency was just terrible, and so you'd move your head a little bit, then the image would go there and catch up. And within 5 seconds of having that headset on, I just felt like I was going to be sick, and clearly this was not going to be the future that I saw there. But that was really kind of the first attempt at doing this, and for many, many years, other companies have been developing new widgets and new displays and building these newer versions of the headsets and saying, oh, this time we really mean it. This is going to be the future and change all the way training is done. But then once you actually put that headset into some kind of an experiment to see what you could really do it, you ran into all sorts of the same kinds of issues. Interfaces with how, when you're fully immersed in a virtual reality environment, how you're able to interface with the outside world to be able to develop muscle memory by touching certain parts of the cockpit. Certain features that you had to do that was really create that training environment. You just couldn't do it. So so the technology languished, and people kept talking about it. But the vision that they had, depending upon who you talk to, I think is captured on this slide. You had people that were building these $20, $30, $40 million domes that wanted that full field of view display, and the only way to get that was putting 10 or 20 projectors into a dome on the outside and spending millions of dollars to put that together. But for certain training applications, you needed it. You had these FTD, flight training device type, that had smaller field of views were okay, but you needed more of a physical cockpit where the instructor could be in there and work with it. But all around, the vision of that was that there had to be some way to get a head-mounted display on there that you could create these sort of lower footprint, much less costly devices where you could do maybe not all the training that you would do in those devices, but enough of the training that was actually going to provide value to that would maybe help you to be more efficient when you finally got into your dome, or more efficient when you got into your full motion simulator here if you were trying to do commercial aviation training. And so that you would spend less time in that more expensive device, and so that you could get more throughput through that, or maybe have less devices overall and end up saving money. So this is the vision I think a lot of people have been trying to do from kind of different perspectives. Even from the sense of these lower cost devices here that had just panel displays in them like you see here. this is great as long as you're looking right out in front of you, but if you're trying to do tack form type exercises and that where you need to see, your wingman that's behind you, then that you just can't do those certain training tasks using that kind of a device. So, but all around is, that desire to get to that, sort of lower footprint device. So I was involved in building, a number of these trials that went around, and about 6 years ago, it is right now, I had some friends I knew that were working with Oculus, and I could see what was coming out with the Oculus Rift, and also seeing what ITTC was doing with the Vive, with the commercial headsets. And so I was at Bohemia at the time, and I said, this is a really interesting opportunity for us, because I think these headsets are going to be the ones that really do it. And so we got some of the headsets. We went to one of our Navy customers and said, hey, this is a good way for you to solve your problem, because they were struggling at the time with pilot shortages, with a lot of the pilots being snapped up by the civil airlines that were experiencing growth in the civil airline training market. And the Navy at that time was experiencing all kinds of issues with OBOGs, problems on T-45, so they couldn't actually fly the airplanes. They needed to do more in simulation. So they were kind of really desperate. And when you're desperate at certain times like that, that's kind of where innovation can happen. So the Navy said, hey, we'll throw some money at you to go and build a prototype. Let's see what you can go do with these new headsets. And so we built a simulator initially for F-18. You could either use an Oculus Rift headset or a HTC Vive. And we actually took that device, took it down to Oceana Naval Air Station, took it into the training rag, and had a whole series of instructor pilots and students come in there and fly the device. And across the board, they all said, this is fantastic. This is really great. I love how I can independently come in here and fly it. There's all kinds of different training I can do. It's not everything that I need to do, but there's a bunch of value in this, with a couple exceptions. They said that the headset doesn't have the required resolutions to be able to read some of the text and all that on there. And then also there was issues with tactile feedback, being able to reach out and touch things and see your hands and your face like that, which, that's really pushing this concept for a requirement for XR, versus pure sort of virtual reality training. And the Navy actually was brilliant here, because they said, we've had enough. I mean, they also went and built a T-45 simulator, and they stuck that in the training facility down at Sinatra. And the thing was they said, we're not sure how to use these devices. We're not sure how they fit into the curriculum. So kind of to Billy's comment this morning, they had their existing training program where you had candidates come in, you had them do a bunch of instructor-led training, then you did a bunch of computer-based training, and eventually you'd get them in there to fly the real aircraft. And of course, they wanted to fly more of it. But that whole process took them a year to get a pilot through there, and that was too expensive for them, and it also just took too long to get that done. They had to have them physically living down in Kingsville, Texas, which is a naval base in the middle of Texas, which is an interesting concept. But they took a step back and they said, okay, we're going to come up with a program to really look at this technology. And that's how they formed what they call the Avenger program. So the Avenger program was something for them to say, we're going to change the curriculum. We're going to have a new way for them to come in. And so the first step in that was for them to put together a bunch of low-cost VR-based devices. So they just bought off-the-shelf VR headsets. They bought gaming chairs. They bought sticks and throttles, Thrustmaster stuff, and through software. Typically Lockheed's prepared 3D in there. And they brought the pilots in, and they had them start to do training. And the government itself did the integration of this, which has pluses and minuses, obviously. But this picture is actually from that exercise. And so they actually have about 50 of these devices that are in use now between Corpus Christi and Kingsville, where they're doing all the T6 training with that. They quickly learned that that was really great with the VR devices, but again, there was only certain training tasks that they train with this, and they said, we really need something that's more XR-based or mixed reality, where you can see your hands and you can reach out and touch, and you had more tactile feedback to get more reps and sets with that. So they put together a plan there and worked in this case with flight safety to build a series of MR devices that had physical cockpits. And so this is actually what they look at, and this is kind of a short marketing video from flight safety, but I think it's got some good content in here, so I'll run this for you.
Flight Safety International's mixed reality flight is unlocking new potential for aviation training. Our latest advancement integrates mixed reality into any existing cockpit training device, combining the tactile benefit of a cockpit with an immersive virtual training environment. Featuring a flexible design, mixed reality flight adds a cost-effective 360-degree visual system to a cockpit training device. Easily integrating directly with the existing host and cockpit, the system allows users to see and interact with the real world inside the cockpit while adding a virtual world outside. Mixed reality flight offers seamless integration with the cutting-edge Varjo mixed reality head-mounted display. The pilot enjoys the highest fidelity headset, allowing clear readability of cockpit elements and a crisp resolution for the virtual world. The addition of a 360-degree visual system allows for extended trainability and situational awareness, including taxi, takeoff, landing, formation flight, mission rehearsal, and more. Formation flight is fully enhanced with a comprehensive field of view, allowing sight for all vectors outside the canopy. This additional capability maximizes the value of an existing device. With ease of use in mind, mixed reality flight adds 2 additional visual displays, allowing instructors to see what the student sees. The instructor benefits from eye tracking, displaying pilot gaze and scan patterns in the real and virtual worlds. If the pilot prefers to use the large forward display instead of the headset, a simple click of a button switches the configuration to a forward field of view. Expand cockpit training capabilities today with Flight Safety's mixed reality flight. Integrated with the innovative Varjo equipment, it raises the bar for cockpit training technology.
So this was a really great, learning experience, because the Navy was looking around and they actually had these tub simulators with the full cockpits that were just sitting around in their lab that nobody used. And once they put the headsets on them and did the integration with that, they became the most popular devices that they had down there, because it was just like flying the real airplane. And so they've since gone on, and they fielded now about a dozen of these, and they're going to field another dozen of these out to various bases where, across the country and eventually across the world, where, and that's really important, because what that allows them to do is, again, that idea of training at the point of need, and not having to pay travel and everything to send the pilot candidates just to Kingsville. They can have them at other remote locations. And so where has this Avenger thing all led to? Most of what they do with Avenger is supplementing a lot of the existing training that they have. So they still have their FTDs that they get into and they train there. They just use them a lot less, and they need less of them, because those are really expensive devices. They were going to upgrade them and everything, and they decided, well, they didn't need to do that, because they only really needed 1 or 2 of those, because they didn't need to do that anymore. But as they looked actually at their next project, which is this brand new helicopter they're getting, the TH-73, they said, you know what? I'll bet you that we can do this without even building the traditional simulators. And so what they did with this is they built or had a higher fidelity version of these low footprint devices built. And so in this case, and this is a picture actually from ITTC there, that they built this a full cockpit. So this was actually built by Frasca. And you see this has all the dials, gauges, and stuff like that, all physical, like in the real helicopter. they implemented a way where you can actually wear the headsets, but you can interact with one another using the mixed reality system. So that each of the pilot and the co-pilot can actually see what the other's doing, and they can react appropriately. And they put higher end control loaders and all that in there that were more realistic than a lot of the gaming stuff that you have in there. And they built a dozen of these, and they sent them out for evaluation. They've been working on that now for about the last year, and they've just made the decision that they're going to put at least another dozen or more of those out, and they're not going to build a traditional sort of simulator capability for this. So this is just really exciting. So instead of having just that one or a couple of these expensive $20, $30 million devices, they're going to build a bunch of these lower footprint devices and field them across the country. So that's the Navy, U.S. Navy, and what they've been doing. Let's talk a little bit about the Air Force, because as they have to go and do their own thing, even though it's very similar to kind of what the Navy did, but because of the different requirements and all the rest of that and different objectives, they took the same basic course, but just did it a little bit differently. And so most of this comes in a project that originated as Pilot Training Next, which was done by Det 24 and the lab down in San Antonio. So Air Force did kind of the same thing. They said, hey, we're going to go and take off-the-shelf technology, a lot of the same technology, prepared 3D, same Velarsim chairs, Thrustmaster, sticks and throttles and all that. The government was going to integrate them themselves in their own lab. So they built those together. They built a bunch of them, and they put them into use. And of course, the feedback from a lot of the pilots was very positive. They did have a kind of a program to do this, where they took a cadre of pilots and they put them through using this technology, and they found out that they were much more efficient. They could get through the thing a lot faster. So there were some great results of that, which led to them coming up with another program, the Pilot Training Transformation. And what Pilot Training Transformation is that they brought in an integrator in this, which is a company called Vertex Solutions. And they looked at adding, again, similar thing, more sophisticated controls, control loaders that were actually specific for the aircraft. And then they started adding in the pieces to do the kind of adaptive training that we just heard a little bit about there. So they hooked up intelligent tutors. That's one fantastic thing about virtual mixed reality devices, is that everything that the pilot's doing is actually instrumented. He's got the headset on, you've got an eye tracker in there, you can see exactly where him or her is looking. You have devices in there that track the hands and where the hands are moving. You have a head tracker on, so you know where that person is looking. And so you know exactly what they're doing. And if you can put some software on the back end of that does human performance assessment, and then actually can do some assessment on that and look at the curriculum and specific scaffolding that you might have in that, they can do all the remediation if necessary, or they can pass that student through there. So a lot of that was done under this Pilot Training Transformation project. And this is actually a picture of the devices that were produced. This is down in San Antonio at the Det 24 facility there, where the pilots can come in there and they can spend as much time as they want and much time as they need with these devices, flying the various training tasks that are built into the software. And those are kind of always changing, because they have different contractors can come in there and add to the capabilities. As with the others, they also had issues with, VR only was great, but there was only certain tasks that you could train with that. And so they're moving forward in a way I'll talk about to do more mixed reality, where you can actually physically interface with real hardware. And an example of that is really this next one here. And so this is a program that spun out of this called Pilot Training Pilot Training Next Advanced. And so this was to meet a requirement. Actually, they had to train T1A pilots that they were flying in actually in the real aircraft, and what they wanted to do was prepare them more and potentially even you remove, this was for the transport pilots, not for the pilots that were going into the fighters. This is for those that are going to, go fly the wide body, low and slow. So with this one, what they were doing was just doing live training in the T1A. And so they built this mixed reality cockpit here, and this was actually done by SAIC. In this, there's two different configurations of them. One of them here, side-by-side configuration. You have certain controls in there that are physical hardware, as you can see there, and others are just wood, because what happens when you put the mixed reality headset on there, you render what those gauges, dials, and all the rest of that look like using computer graphics, and it seamlessly gets mixed together. So when the pilot looks at this through the headset, they're able to see the physical controls that they need. Everything else is graphically generated. So, and again, with this, you have the side-by-side way where you can actually see each other and interact with each other. And then they have two versions of that. One is this sort of fixed-base device, and then they can also take that and stick that in one of these Redbirds. So that's actually a, Redbird motion simulator that typically has a Cessna 172 or something in there. They took that out, and instead they put this device here into that, so they can actually do some motion-based training with the headsets on, with the pilots in there. And so they move the pilots through there. And I'll talk about the results of that in a moment. So they worked on this in stages, developed more sophisticated versions of that. And all the time they're adding new capabilities and the ability to train more and more tasks. So the big question that I'm sure a lot of you have is sort of what is the effectiveness of all this and what are the results? And so the good thing about this is that we're finally actually getting some real results on this. And I shamelessly stole this from a presentation that was made at ITTC a couple of weeks ago by Vertex Solutions that talks about this. And so the results of this are just better than expected kind of across the board. So Embry-Riddle, with these VR devices that they're using now, they're finding out that pilots can get through this and they can solo in 30% less time than they could before. That's a huge bonus and cost savings for anybody that's going through to become a private pilot, especially if they're trying to transition through to be a commercial pilot. Even better results coming out of the Air Force. So they're between looking at solo times in half, the ability to move through all of the different training times in a fraction of the time as at what they did before. They've cut the entire training time by 4 to 6 months, from a year. So they've almost cut it in half to get these qualified pilots and all that through the system, which is incredibly exciting. And then last but not least, with the T1A, where they were having the transport pilots go through to get their basic pilot training on the T1A, they completely eliminated the need to fly in the real airplane. So they train and they have about 50 of these devices now for the T1A, where they put the pilots through that and then they take them directly there to the wide body airplanes and fly them there. So that's fantastic results that are coming out of there. And then similar with the Navy, they're not quite as positive and aggressive yet, although there is a study that I hear just came out of NOCTSD that I haven't really seen through yet, but they're talking between 2 to 4 months less time to train the basic pilots in that. So so this stuff is for real. It's really happening, and there's some real great results that are coming out of this. And then the other sort of elephant in the room that we look at a lot, and that's the whole idea of civil aviation. So the civil aviation training is something that I know my management at Varjo was originally very excited about being part of this, and I said, well, with the regulations of the FAA and EASA and all the rest of that, it's going to take a little bit longer time to get through that. And I was certainly right there, and it took a number of years of us sort of working this with different companies. We actually made some real major progress last year in that a Swiss company we're working with here called VRM in Switzerland, actually working very closely with EASA, managed to get approval from EASA to actually log flight hours on a HMD-based Robinson simulator here. So it's 20 or 30% of the training time that you can log on the device. So it's not sort of the full time that you would like to see, but it's a big step to get an agency like EASA willing to stand up and say that they're going to be able to do this. And so I think we're going to see a lot more of that coming, just because of back to the idea of the requirement is so big to get more pilots through through training, get them through faster, and be more effective. So I've sort of touched on all of these as I've gone along, but there's just tons of benefits to using this kind of XR technology. I always try to talk about it as to think about it initially, it's to supplement a lot of the existing training that you were doing rather than sort of replacing everything that you've done in the past. People tend to be much more comfortable with thinking and working with it that way. But as you're seeing, in many cases, it is actually replacing some of the training that they're doing. The pilots like it. They come in at Sinatra, and on the first day they get there, instead of sitting through a lecture for hours, they're in there on the devices. And so it's they're excited about doing it. They do it on their own time even. And what that does is that really increases their velocity about just getting through the program faster and being able to do it, because they come in there and they want to fly, and so at least this gives them one step of that right away to get there faster by using the XR type devices. The one other thing, so I talked about portability, point of need, that's really important, but I think the last one here, and this ties a little bit more into what Billy's talking about, you can train a lot of things on these devices that you can't do in the traditional simulators, and that you're going to have to do because you can't train on the ranges anymore because of security issues and the sensors that are on the Gen 5 aircraft and things like that. And so I'll talk a little bit about where all that's going, but that's a big benefit that I think we're going to see going forward. So what's next? So that's kind of where they are right now. But the next big step in this is a contract that was just awarded by the Air Force, DET 24 again, that did pilot training next and all that. This is through DIU, the Defense Innovation Unit. They just awarded a contract, won by Vertex Systems with Metria, was a company that was going to be here today, where they are going to be taking this to the next level and look at the sort of fighter bomber fundamentals in here. So rather than just the basic undergraduate pilot training, they're looking at more higher level training that they're going to do for fighter bombers. And so the initial target on these is T-38s, F-16s, and also looking at T-7 and being able to provide primary training capabilities for that. And so within this is another short-term 18-month project where they're going to rapidly field these and put a little bit more money in to do this. All of this is going to be mixed reality. The second project here is one that I think you guys will find very interesting, and that is, the Air Force has really realized that with all the 5th gen fighters, they can't train on the ranges. Ranges are too small, too many security issues with that, with people listening either with balloons or with other sensors that sit at the edges of the ranges. So they're building what I call this Thunderdome facility here, which was going to be a whole huge complex full of domes where they could go in there and really what they're trying to do here is develop ConOps, for the Gen 5 aircraft and then do certain training and all that. It's really all this is targeted toward China. And instead of building the domes, they've decided that first of all, it would have taken them 2.5 years to build the buildings that they were going to put the domes in, and that was problematic. So for a fraction of the money, they could not have to build all the buildings, and instead of that, they can get a bunch of mixed reality devices in there that are going to be used to build out this capability to do all of this training, ConOps development, and all that. And so that's going to be in combination with stuff that's happening at Nellis and at Edwards Air Force Bases, so that's a huge new program called VTTC, the Virtual Test and Training Center. And actually, there's one other one here that has been awarded since I sent my slides in, and that is one that we're involved in now with the Army. So not to leave the Army out of this, the Army's finally getting on board on this. They have a project called STE, Synthetic Training Environment, that U.S. Army PEO STRI has been working on now for 5-6 years. And we just had an award from them. As part of that project, they have an air component where they're training Apache pilots and Kiowa, a couple other versions, and they have decided that they're going to do all of that in these portable trainers that literally goes in a big Pelican case. You can fold it up, and they're going to put on the head-mounted displays and be able to do all their training. And that's thousands of systems that are going to get deployed on that. So that's by far the biggest opportunity that we at Varjo have ever gotten into, and we actually worked very closely with them to build some custom capabilities into the headsets to help to develop that. But that's the RVCT, the reconfigurable virtual collective trainer. Try to keep all these acronyms straight. So that's another one that's going to be is awarded, it's funded, and it's going into production here as we speak. And then last but not least, our friends at the FAA are finally stepping up and saying, this is interesting. We could probably train a lot of the typical civil airline pilot training that we do on these types of devices. But first of all, we have no idea how to do that because all of our methodologies for all the test and training is based on traditional collimated displays and all that. And so they said, hey, we're going to put out a cooperative research and development agreement, try to make an award on this and to get people to and figure that out because they've got big issues now with eVTOLs and the vertical takeoff and landing and those types of training that they're going to need to look at, and all of that's going to end up going to XR type training applications, and so that's got to happen. So that's my time, and I know that's a lot of stuff, but hopefully does anybody have any questions?
I got a question for you.
Yes.
So obviously I'm a big proponent of mixed reality and virtual reality, and we're about to go over to our sim center and we'll see where we're using some of your technology in our sim center. But I also get the opportunity to go around to different technical shows, ITSEC down in Orlando, and the headsets are awesome, but they're not quite plug and play. There is some calibration required. So what, if anything, is Varjo doing to support its users to avoid a guy like me going to these shows, putting on a headset, getting out and saying, it's crap, we need a dome, or an alternate headset?
That's a loaded question. So you're right. We don't control everything around here in terms of the different software we use, and that's a lot of people think that's a benefit. So we can support different IGs and different software packages, and we don't sort of tie people into that. But it does create certain challenges in how things are implemented. And so one thing that we're doing is we're spending a lot of time with standard organizations trying to come up with a set of standards for how headsets talk to the software. And so we think what that's going to do is that's going to improve the all-around availability of better software, make it easier to do the implementations, and so that you don't have to be have your real experts from whatever company it is that's going to spend the time doing the development with that, and to be able to get to better solutions, because we think that because there's a lot of stuff happening there. You've got chroma key that you're using to block out certain things, and you're using digital masking techniques, and you're trying to match up the real and the virtual world so things blend together right, and just simple issues about having enough light on the subject, and And then how do you do, implement NVGs and stuff with that? So there's a lot of complications, and if you don't have anything right, and you walk up to something at a show and you see that, somebody could say, well, this just isn't good enough, I want to go do that. So we have an entire group within the company that's focused on trying to come up with these better solutions, better software solutions. And then what we're trying to do is work directly with a lot of the end users. So for example, on the VTTC program, what we're actually doing is we're cooperatively working with the customer. So as we bring out new prototypes of next generation technology, they actually get it first into their lab before we've even announced it. And they have the ability to kind of see it, make comments on it and things like that. And what we do from that is we go back and we make, it's not we're designing something for them, but we make certain trade-offs that are going to benefit what they do, because we know that if we do that, they're going to buy a lot of these. And also that's going to be a technology that they can use to kind of solve those problems. So it's cooperation between the software developers, focuses on standards to make everybody able to get to this, and last but not least, working closely with the end users so that we can actually show them the potential of this. And then last is me groveling on the floor to try and get people to put the headset on. Because many of you are like I was back in the 80s when you put the thing on and you said, I'm done, I'm never going to do this again, and you haven't done it since then. Well, it's a lot different now with the optics and all the rest of that stuff. It's not something that's going to make you sick, but sometimes groveling is in order to try to get people to put the headset on.
Awesome. Well, thank you very much for the comprehensive presentation.
Thanks, appreciate it. Oh, thank you.
Thank you.